Hi, this is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we might find interesting. Today we have a guest, Burkhard Stubert from Germany, and he's going to talk with us about Qt and Yocto and various other topics that he works with. Maybe you could start off, Burkhard, with telling us about the type of work you do and kind of what you're doing these days.
Sure. Hi, Cliff, and hi, Kim. Nice that you have me on your podcast. It's a pleasure. And yes, so I specialize in building HMIs for industrial machinery. So my marquee projects are driver terminals for, forage harvesters and sugar beet harvesters. So it's the huge 750 horsepower harvesters, so 80 meters long, 60 tons, something like that.
Mm-hmm.
And for metal bending machines, you can do metal origami with it, pretty fancy stuff. And then in nearby areas, so built two infotainment systems, one for a US car maker, one for a European one. Built an e-bike, and they are pretty similar to cars and harvesters these days. They have a CAN network on board, which is amazing. And yeah, so that's my marquee projects. And what I typically for the HMI, I typically use Qt, and then I also help my customers build the Linux system, customize it. It's typically a Yocto-based Linux system. Haven't had a build root one for years now. And then it's the whole system. So it's the interaction with the user, and it's also the communication and the control of the machine. So you can actually on a harvester you can do a lot more than on a car. You can actually fine-tune the motor or so if you have the rights to do that, which as a developer you always have. So
Sure.
you have to be careful. You can actually wreck the motor.
Mm-hmm.
So I leave that to the people at my customers.
So a lot of CAN bus communication and
Canvas, yeah, that's actually a red thread through my 10 years of solo consulting, and it's now I think the fourth project with CAN bus, three of them with J1939. So the construction machines and agriculture machines use J1939. So wrote a couple of code generators and built the whole communication multiple times. I would love to do that once and then keep the usage rights to that and then sell that as a fixed component to companies. And I'm always wondering, why is everyone reinventing the wheel, doing it again, doing it badly typically, and why not build it once and then buy it for a fixed price? But they don't want to give me the usage rights for what I'm doing.
Yeah.
But
Yeah.
I think that's a topic we will come back when we talk about Yocto a bit more. Companies doing the same over and over again.
Mm-hmm. Yeah, after doing something 2 or 3 times, you kind of get an idea how it should be done.
Yeah.
So that's very true.
Otherwise, you do something wrong.
Yeah.
If you don't see the patterns.
Sure.
Yeah, and I've been a solo consultant for 10 years now, and doing always embedded development, always HMIs for embedded devices. And before that, I worked for Nokia, for the Qt business unit of Nokia in Norway. Before that, for high-tech consultancy in England. And for my start was with Siemens and Infineon in Germany. So but now I'm back in Germany, a bit east of Munich, enjoying many mountain hikes.
Oh, that's cool.
Wonderful.
So you mentioned that nowadays you work with Qt and Yocto. So how did you get into doing Qt and Yocto? Could you kind of tell us?
Yeah, it's into Qt. That's an interesting story. So I started working with Siemens in '97, and we built. I was tasked to build a GUI for formal verification tool. which is still available, by the way, and most of my work is still available after, 26 years. And I did it with Java, which was all the rage at the time, and I got burned really heavily because the GUI was running remotely on a SunSpark station, and then beamed, so every bit walked over to the client side, and so it was painful to see the GUI being built up pixel by pixel. So that wasn't accepted by the customer, and then we looked around and found Qt, which was, I think, created in '96, so it was 2 years old, or 3 years old at that time, but was pretty good. And then we decided to redo the GUI in Qt, which was version 1.44. That was my first Qt version. So then I've been doing all the migrations from 1 to 2 to 3 to 4 to 5 to 6 now. So yeah, that's how it started, and that got me into Qt. And then Yocto came a lot later because it didn't exist at that time. So you had, I got into embedded in 2006, and at that time you had wonderful build systems like LTIP. So you better jumped out of the window because that was really painful to work with. It's still around, so I came across it some years back for a TopCon A3 terminal. They still use LTIP. Amazing. And then came Yocto, and that was a lot easier. I think my first embedded system where I built Linux myself was Buildroot. And then after that, I needed 3 or 4 attempts to get into Yocto. So the initial learning curve is extremely steep.
Yeah.
And on the 3rd attempt, I really got over the hurdle. And from then on, it was a lot of Yocto projects. So it's just Yocto. I think the occasional Buildroot project, and that's it. Some people are crazy enough to use a desktop Ubuntu on their embedded devices. But,
so that's a good question. Why should we use Yocto instead of Ubuntu?
Well, I had the metal sheet bending machines I mentioned. They had huge terminals, so that's a display computer actually, with an AMD processor inside, and they decided to use Ubuntu desktop. So you basically have to cripple it. So you do not want the user to sneak behind your application and use it as a normal desktop operating system. So you need kiosk mode if that's working properly. But then you don't want to allow normal mouse movements, and so you really have to forbid a lot of things, and it's pretty difficult, I think, to forbid all these things, to make it impossible. And then the updating process, that might be the customer. It was a 40-step manual process to flash a new Ubuntu system. You probably could do it faster, but it's a lot easier with Yocto. You can start with a much smaller system. You could say a minimal system. Well, there's a lot of bloatware in there these days. You have to get rid of that, but it's fairly easy. It's from your image recipe. You just remove it. You start with a small system and you add the things you need. So I find it simpler than to remove things you don't want.
That's fascinating. So you start with a small system, add the stuff you need, instead of starting with a bloated system and try to pare it down. So yeah, that's an excellent description of the difference.
Yeah, I think my experience is cutting things down takes much more effort than adding the thing you need. Or maybe occasionally you remove things you don't need, but it's all very simple in Yocto. it's typically just removing a line in your image recipe or adding one.
Mm-hmm.
That's extremely simple. Do that in Ubuntu. Yeah, you have a package manager, and you have to use the package manager for updates. No, then you need a server serving just the packages you want to allow on the system. So that's another effort. You can solve all these problems. The e-bike system that was using Debian actually, but they had to hire a Debian specialist for a lot of money to get the Debian system compile everything correctly for some Chinese SOC, ARM-based SOC. So and that guy wasn't available for some time, so they actually had a delay in their schedule, and it's difficult, I would say. So it's a lot simpler these days with Yocto, and it got a lot simpler over the years. So typically you get a BSP which builds. That's a good start. There may be a bit too much in it, so the Qt company always puts a lot of demos in there which you don't want and which you will never need. So you have to get rid of these and some other things, but it's fairly straightforward.
Yeah, so it's basically you're building a full system from source, and that's a big task. And
it is, and you need a very fast computer.
Mm-hmm.
So under my desk here, you have a build server with 2 Xeon processors in there.
Mm-hmm.
A lot of memory, and I think 32 cores. So I can build a good sized Linux system from scratch in 30 to 40 minutes.
Mm-hmm.
And that's what you need. So it was a really good buy, this server. So it was worth I think 7,000 euros or so. That was really good.
Yeah.
So speaking of like Qt, so being kind of, I reckon, involved in it from its infancy and until now. So, there was some migrations that happened, and like Qt 4 was prevalent for a long time, and then Qt 5 came, and then now Qt 6. So what were your experiences of like porting different applications from one to another, and some of the new things that you found interesting, and how was all that journey for you?
The port or the migration from Qt 3 to Qt 4, that was the worst one. I actually ported, that was when I was in England, I ported an IDE for Bluetooth development used by CSR, now part of Qualcomm. I ported that from Qt 3 to Qt 4, a complete IDE. Took me, I think, 8 months in the end. So we were estimating something like 4 to 5 months, and that was a cautionary estimate already, and we were still off way. So they changed far too much. So you basically. They introduced a proper model view architecture for the list views and so on. So you rewrote large parts of the code. And so that was a really bad experience, but the other ones were basically trivial. So I just last year or 2 years ago, last year I think when Qt 6 came out, I ported the terminal application for the sugar beet harvester, where I still have the sources. I just ported that for fun from Qt 5 to Qt 6. Took me 2 days, I think, 2 or 3 days, and then it was done. And that's about how much it should be, and it's a pretty easy, pretty smooth migration. And they learned their lesson, so they put a lot of effort into making things similar. So the last Qt 5 version is very similar to Qt 6, and so you port first to Qt 5.15, and then you port to Qt 6. So they also learned the lesson. I guess they were beaten up heavily for the Qt3 to Qt4 migration.
Yeah. So as we look at Qt, they have a QML. It's more of a declarative way to program, and then they have the older style C++ widgets. What do you see these days? What do you use, and do you have any thoughts on that?
On embedded devices, it's pretty easy. It's QML or Qt Quick is the way to go, and the main reason for that is, well, it's the simplicity of the language. Obviously, with Qt widgets you're writing in C++. With QML you write in it's basically property and value, or a simple expression, and with the then you have some touch or mouse or key handlers, and that's 1 or 2 lines of JavaScript, typically calling into C++ models if you do it right. And so it's very simple. People can learn QML very quickly. I just had on my current project someone who had never done QML, had a little bit of experience in C, that was it, got the training, and then he did the large parts of the HMI of an excavator terminal, which is amazing. And you still see it, so he can still learn a bit, but it's okay. It's working. Customer is happy. So what else do you need? And technically the reason for this decision is QML can be graphics accelerated. So it's easy to accelerate it with OpenGL. And these days, most of the time you have a GPU on board which can do OpenGL acceleration, and there's rarely one without. And the IMX7s are a big exception, for example.
Sure.
But the others, the IMX6 does that fantastic, and you can get very fluid, very smooth animations and so on. And so that's the technical reason. And recently I did one project again with Qt widgets. The customer decided that before I joined the project. It's hard work, and it's about. I once measured it. I did Löwe, the German TV luxury TV maker. I think by now defunct. It's the way. They did a prototype with Qt widgets for their TV, and then they asked me, "Hey, can you show us how you can do it in QML?" Or they actually first wanted me to do it to overhaul it in with Qt widgets, and I said, "No way." So, and I do it in QML. It's much faster, nicer animations, and so on. And I reduced 20,000 lines of code to something like below 2,000 lines of code. Wow. And that's pretty typical. And it's easy code. So you don't have to think about how to implement an animation. You just say it's an animation of that kind. You want to animate, say, the position. Then you animate the position, but you don't have to implement how you do that. So you don't have to look at the internals. So, and that's pretty typical for QML. So it's, I think, the best thing that happened to Qt going to QML, and that's the envy of many other GUI frameworks. Makes life so much easier.
Interesting.
Speaking of,
sorry, go ahead.
Yeah, speaking of the GUI frameworks, right? So there are kind of always this question. It has been always there. What different frameworks to use? You got some of the desktop-ish kind of GTK, and then you got like Qt, and then you got nowadays web platforms, which kind of like was very famous, or quite popular in adoption, especially in last few years after the browsers came along. So, what are like good applications that you think that fit Qt, and some of the trade-offs, that are between, say, all these different technologies and platforms?
On embedded devices, I think your best bet is Qt and especially QML.
Mm-hmm.
And I think I mentioned the reasons. If you compare it, so I did a comparison for a home appliance maker between QML, writing their GUI in QML, and writing it with, I think it was Angular at that time, but you could put any other fashionable web framework there. And well, we could work out that to get, say, smooth animations, which is trivial with QML, to get that working with a web framework, it's difficult. And you actually see that if you look at what Netflix has been doing, they are using some self-written web framework. So they got rid of basically nearly everything and every HTML and most of the CSS, because CSS does in the end some tree transformations, global tree transformations you can do, so don't use that. And they settled with a lot of JavaScript, rewrote their GUI library in JavaScript and optimized that over years and personal years of effort for their TVs. I still say the experience there sucks. It's okay, they have the trouble, they have a large spectrum of different hardware with or without graphics acceleration, which doesn't make it easier, but it's a painful user experience. Even if you look at something like Apple TV, which is definitely native, and I think some of the third-party apps, they are not native, they are web, they should be web. It's challenging, so it's clear. It's look at the size of say Qt web engine, 100 megabytes on the hard disk. You can probably, the Chromium browser I found is 40 megabytes, and you need the complete engine of whatever you are using. And nowadays, Qt comes with a Chromium engine.
Right.
libqt web engine is 100 megabyte. You can probably bring that down to 80 or 60, but I don't care. That's an effort I don't have to spend. The QML engine comes in at 6 or 8 megabytes. Mm-hmm. Okay, you need that space on your flash drive, on your SSD, and if you load it, it takes ages, and you have to load it.
Yeah.
You probably don't need 99% of the features in the web engine because they take time. So and so you have to load it. The startup times are slow. You can't. In a car, you have to be able to interact with the GUI within typically 2 seconds. That's what you get. Well, the navigation is always excluded because they can't do it under 5 or 6 seconds. Mm-hmm. And you typically boot up the system when you press the key fob, so you get some extra seconds. But the requirement is 2 seconds. You can't do that with web. Just loading that takes time, and the startup time is dominated by the time by the size of your file you're reading in, of your binary, and that's already huge with web. So that's one thing, and the other thing is I've seen web applications on embedded devices. Animations are never smooth. They're always jerky, and it's hard to accelerate these things properly. It's not as simple as with QML, which maps very nicely on and directly on OpenGL. So yeah, it's and then we came, if we wanted the same user experience with a web framework on these home appliances, we would have to take a more powerful SOC. So we would have to move, say, from an IMX 8 wasn't even available at that time. So the IMX 6 wouldn't really do. Or they could, with QML, they could even stay with an IMX 5. So, and that means you're saving money if you can go to a smaller, less powerful SOC. That means you saved there, you would have saved something like $11 per device. And if you multiply that by 1 million devices or even more, that's a substantial cost saving.
So one processor we see a lot is the IMX 6 UL, kind of more for headless gateways. Would QML run on that processor?
I think, if I'm not mistaken, it doesn't have OpenGL acceleration.
That's right. Yeah.
So yes, QML runs on it. Absolutely. QML also runs without hardware acceleration, so it's then software rendering, complete software rendering. So you will see the CPU load go up.
Sure.
But I got it running on what was it? IMX 31 and 27. So, but that was QWidgets software rendering.
Yeah.
That's another reason why QWidgets isn't a good choice. It's extremely hard to graphic accelerate it because it's an imperative language. So where you always say what you are doing, and that's the benefit of of a declarative language like QML. It's you have more degrees of freedom to optimize things in the way you can move them easily around, and same is and it's the same thing with web. But you can run QML on an IMX 2731, so without graphics acceleration. I've done some projects on that. You should avoid animations. You can get a speedometer needle pretty smooth, but you shouldn't try to have, say, 5 needles in parallel. So that would be pushing your luck.
Yeah.
Or full screen animations. Okay. Yeah, they will drop some frames then.
Sure. Okay.
It's not a pure all. So if you have no graphics acceleration, you have to tone down your expectations.
Sure. Yeah, that makes sense. Yeah.
No 3D graphics, sorry.
Yeah.
Yeah.
Yeah. So I think you've been building systems, right, for many years, and I'm pretty sure you have kind of developed some templates or some aspects of building these complex systems, whether it is Yocto or some others prior to that. So do you have any tips or your best methods of using CI in this kind of modern systems nowadays, which are quite complex?
I'm just getting into I'm just about to set up my first continuous delivery pipeline for a Linux system. Have done one for an application which still ran on a desktop. So I'm still pretty new in that. So ask me in 2 months or so, and I can tell you a lot more how that's working. I think
probably we'll look for a newsletter from you and some entries in there.
Hang on, I was thinking about something. Well, if you look at the architecture side, so of your main application, which is typically running on your system, then my experience, what I worked out over the last years or understood over the last years, so my starting point there is the so-called ports and adapters architecture, also known as hexagonal architecture, which, the main idea is your business logic has several ports. So typically you have a port to do the machine communication. You have one to talk to the database. You always have a database. You talk to the cloud nowadays, and you have a port to the GUI. So that's your standard ports. And a port is an interface. And what is for the business logic, what's behind the port? So how you do the communication with your electronic control units on a harvester, it doesn't matter. So the rest of the application doesn't know. It's just this adapter adapts, say, the CAN communication to your interface, which doesn't know anything about CAN communication. So you could use Ethernet instead, or broader reach, or whatever is the next range, or just move from basic CAN to CAN FD to CAN XL, or from chain 1939 to, I don't know, CAN Open or OPC UA, or whatever you want. And it doesn't matter. The rest of the application doesn't see it. You can flip out the database, say, and many use an SQL database. Why? You typically should use a time series database for the data on harvesters and tractors and construction machines. That might be more suitable. Or you can use the adapter for the GUI. You can write your acceptance tests, so mimicking what the user does, as another adapter for the GUI port. And you have a fantastic way to test your whole system.
Yeah.
And that's these days, that's my starting point. And if I come into a legacy project, I would first check their architecture and try to find out where they have problems, where they don't have this clear separation of business logic in the core and then the ports and the adapters around it. And so that saves you a lot of time. And when it comes to Yocto, I think some basic tricks are definitely find a SOC or SOM or terminal manufacturer who has a pretty recent Yocto version. So there are too many around there. So my current one is still on Yocto 2.7. So now try to fix, what really happened there is the cameras, so heavy duty cameras on an excavator. The video streamed to Qt 6 is delayed by 3 seconds. And so I tried a couple of fixes. That's a Qt problem, by the way, but it's exacerbated by the fact that we are still on 2.7. So I have to build Qt outside the Yocto build against the SDK. That's the quickest way to build Qt 6. Otherwise, integrating it into a very old Yocto, have fun with that. That's a lot of effort. And and then you might have to build the libraries Qt Multimedia depends on as well, because you have very old versions, and so you have a long tail of things you have to do.
Yeah.
So get a recent BSP and select the SOC or SOM for a very recent one. Make sure that you can build it easily. So I don't know a BSP which comes where you can do a one-on build, which would be ideal for CI/CD pipeline. There is none, and if you want to have that, I would suggest you use CAS, which is basically a Docker container which does Yocto builds. You describe the layers that you need in a YAML file, which is extremely simple, and you throw the YAML file at CAS, and it builds it, and it's working. So that's the one command build you need for a CI/CD pipeline, and that's an excellent starting point. And then probably with the pipeline, you should definitely have several stages. You don't build the Linux system in first stage, in the so-called commit stage. The commit stage just runs your unit tests, and to make sure that your changes which you are about to commit most likely don't break anything. So you want a high confidence that nothing is broken, and that should work in less than 5 minutes, no matter how big or complicated your system is. Mm-hmm. That's normally, had a client last year, their build times were at 45 minutes or so. And yeah, they were building the whole system. You just have to build the tests and not the whole system. Yeah. And if one of the tests fails, you say, okay, you can't integrate your change. Something is wrong, and you fix it. And then, of course, in the commit stage, the result is an application, a binary, which you can install on the device. And then in the acceptance stage, so where you obviously run acceptance tests, so that's basically what the user would do, how the user interacts with your system. You automatically install things on your device as the end of the build, and then you run the acceptance tests and on the device, in the real environment, in the production environment in the end. And then you have you can run some static analysis or dynamic analysis, or the sanitizers, for example. You probably run you can run them in the acceptance stage, or even earlier in the commit stage. And then you have a third stage, which I call the system stage, and that's where you would build your Linux system with Yocto. And that's a lot slower. You do not have that many changes anyway. You might have, while you are ramping it up, while you are creating your customized Linux system, you might have some more, but you can't kick off a build whenever you do a change. It takes too long. So you probably, if you know your build server, you build it every hour or every 2 hours, or just over the night. That might be okay. Yeah. Or just the person working on it will build it locally or so, or will trigger the build manually. Yeah. But then if you do it automatically, then do it every 2 hours, or when the load on your build and pipeline servers is low. So you have to get it off the beaten path. So yeah, that's a bit, that's what I learned. So I helped maker of professional appliances last year to introduce continuous delivery. So the practices and principles which go to both team and software architecture. So it influences both and conveys law, fits the things together. And so they had to build the pipeline. So we together defined it. So basically what I just told you here, and then they did the implementation. So they had a little infrastructure team doing the pipeline with Jenkins actually. So we got down the build times of the whole system to something like, on average, I think something like 10-12 minutes. So that's quite good, from 45 to 50 minutes. And if you run, we ramped up the testing, introduced TDD and trunk-based development and all the continuous delivery practices, or many of them, step by step. And now they are in a lot better shape.
Yeah, those are great ideas. Appreciate you sharing those. We will continue this conversation in the next episode of the Tempter podcast, so please join us then to hear the rest of the conversation with Burkhard Stubert. Thank you.